I'm John Kusidu. Let's do some math. In the next few videos, I'm going to be solving problems applying the exponential rules. In this first problem, we have 3 squared times 3 to the 4th. What does that mean? That's 3 times 3 multiplying 4 factors of 3. By definition, that's 6 factors of 3, or 3 to the 6th. Next, we have 5 to the 4 times 5 to the 7th. Now, I could do this the same way, multiply 4 factors of 5 by 7 factors of 5 for 11 factors of 5, but as these numbers increase, the exponential numbers increase, the amount of work that we have to do, the amount of writing that we have to do increases tremendously. So instead, let's apply the product rule. The product rule says that if the base in the exponential expressions is the same, we can just add the exponents. So 5 to the 4 plus 7 is 5 to the 11th. Next, we're going to look at a little bit of an excursion into exponential algebraic notation. S here represents any number, a variable. So instead of being a regular number, it could be a symbol that represents any number, which differs depending on the situation. All that matters in applying the product rule is that the base, the letter, is exactly the same in both expressions. So they're both s's, so we just have to add the exponents. So this is s to the 7th. Same thing here. We have u to the 4 times u to the 5th. And again, that's u to the 4 plus 5, or u to the 9th. Now, these variables don't have to be English letters. They could be Greek letters. They could be just general symbols like square, triangle, circle. As long as the expression, the symbol in the expression is the same. So something like triangles to the 4th times triangle to the 5th, that would be triangle to the 4 plus 5, which is triangle to the 9th. It doesn't matter. It may look strange, but it's the same thing. Now, let's look at this last one here. We have x cubed times y to the 5th. Now, in this problem, we can't apply the product rule because, yes, these are both exponential expressions, but the base is different in each factor. In this factor, the base is x. In this factor, the base is y. So we can't simplify this using the product rule. Next, let's look at some division problems. These were all multiplication problems. In the first one here, we have 3 to the 7 divided by 3 cubed. Next, we have 2 to the 12 divided by 2 to the 8. We have x to the 7 divided by x to the 5th. We have t to the 15th divided by t to the 9th. And last, we have u to the 5th divided by v squared. Now, as I said, these are division problems, so 3 to the 7th divided by 3 cubed could be rewritten as 3 to the 7th divided by 3 cubed that way, which is what? 3 to the 7 means 7 factors of 3 in the numerator, 3, 6, 7, divided by 3 factors of 3 in the denominator. Now, how do you simplify that? Well, we can use a process called cancellation, which means that we're dividing each factor in the numerator by the same non-zero factor in the denominator. So we're going to divide here by 3. We're going to divide there by 3. Divide here by 3. Divide there by 3. Divide here by 3. Divide there by 3. But what happens when you divide a number by itself? 3 divided by 3 is 1. 3 divided by 3 is 1. 3 divided by 3 is 1. So we have 3 factors of 1 now there. Same thing here. 3 divided by 3 is 1. 1 and 1. 1 times 1 times 1. What's left? 3 times 3 times 3 times 3. Now, no matter how many 1s you have, the product is going to be a 1. So this is 1 multiplying 3 times 3 times 3 times 3. 3 times 3 times 3 times 3, which by definition is 3 to the 4th over 1, or just 3 to the 4th. But instead of going through all of this, we just have to use the quotient rule, which says that if you have two exponential expressions in which the base is the same, all that you have to do is subtract the exponent of the denominator expression from the exponent of the numerator expression. So 3 to the 7 over 3 cubed is equal to 3 to the 7 minus 3, or 3 to the 4th. Same thing with much less work. Next we have 2 to the 12 divided by 2 to the 8. Now, as these exponents get bigger and bigger, that means a lot more writing. So instead of writing out 12 factors of 2 in the numerator and 8 factors of 2 in the denominator, canceling 8 2's in the denominator and 8 2's in the numerator, leaving 4 2's in the numerator, let's go directly to the quotient rule. The bases are the same, so we can just take 2 to the 12 minus 8, or 2 to the 4. Next, let's look at a variable situation, x to the 7th divided by x to the 5. Now, one thing about variables when we're doing division problems, because this one is equal to x to the 7th divided by x to the 5th. We're not allowed to divide by 0 because it has no meaning. Division by 0 doesn't mean anything. So these variables can be any number except 0. So again, instead of writing 7 factors of x in the numerator and 7 factors of x, 5 factors of x in the denominator, and then canceling 5 factors in the denominator, 5 factors in the numerator, leaving 2 factors in the numerator, let's just go straight to the quotient rule and subtract the exponents, which is x squared. Next we have t to the 15 over t to the 9th. Same situation. T can be any number except 0. And I'm not going to put 15 factors of t in the numerator and 9 in the denominator. We're going to directly go to the quotient rule, t to the 15th minus 9, or just t to the 6th. Now this last one is different because we have u to the 5th over v squared. Now, we can't apply the quotient rule to this because yes, they're both exponential expressions, but the bases are different. In the numerator, we have a base of u. In the denominator, we have a base of v. So this cannot be simplified by applying the quotient rule. All of this and much more is covered in the Pre-Algebra workbook series that's linked to in the description. Thank you for watching.